This will be lesson 10-2. Today's objective: all students will be able to define and apply properties of arcs, and central angles. Well, the first thing we need to talk about is what is a central angle. Well, if we look at a circle and I draw an angle such that the vertex of the angle is at the center of the circle, this angle is my central angle. The angle has its vertex at the center of the circle. An arc is an unbroken part of a circle. If we look at just this part of the circle right here, where one end is right here and it moves along to this end, from here to here, this is an arc of that circle. Let's call this circle O, and 2 points on that circle are going to be Y and Z. What we say is that arc YZ from this Y to this Z is called a minor arc. This is called a minor arc. A minor arc. And we say that arc from Y to Z along this direction, this is called a major arc. If points Y and Z are the endpoints of the diameter of the circle, we would say that the two arcs that would be formed are called semicircles. So semicircles are formed if those points on the circle are the endpoints of a diameter. The notation that we use for a minor arc is we use two letters, the two endpoints, Y and Z, and we draw an arc over those two letters. We need three letters to represent a major arc, so I'm going to call this point over here W, and we're going to name that major arc YWZ, and we'll put an arc over that. Sorry for any delays writing this out. I'm just trying to figure some stuff out from the software as I go along. Alright, now we need to talk about the measure of an arc. So again, let's draw this circle. Let's call it circle O. And again, let's have this minor arc YZ. We say that the measure of a minor arc is the measure of its central angle. So the measure of a minor arc is equal to the measure of its central angle. So we measure arcs in degrees. For example, we'll say that the measure of arc YZ, and that's the notation we're going to use, is equal to the measure of angle YOZ. Angle YOZ. Let me see if I can erase that now. Well, I don't know why I won't erase. Well, that's supposed to be angle. Let me cross that out. I don't know why I wouldn't erase. The measure of angle YOZ. Alright. Now, the measure of the major arc let's say we had major arc YWZ. The measure of the major arc is equal to 360 degrees minus the measure of its minor arc. Minus the measure of its minor arc. So the measure of arc, see that erased that time. The measure of arc YWZ is equal to 360 degrees minus the measure of arc YZ. Okay, now let's give another definition. Adjacent arcs. Let's say I have a circle, and let's call this point A on the circle, let's call this point B, and let's call this point C. And then we'll call this circle as O. Adjacent arcs of a circle are arcs that have exactly one point in common. So if you take a look at arc AB, and you take a look at arc BC, notice that they have exactly one point in common, point B. So we say that the arc AB and arc BC are adjacent arcs. Now, using this, we can write a postulate. This will be postulate 10.1, and it's going to be called the arc addition postulate. In our homework book, it is going to be homework postulate 16. And it states that the measure of the arc formed by two adjacent arcs is the sum of the measures of these two arcs. The measure of the arc formed by two adjacent arcs is the sum of the measures of these two arcs. For example, in our picture above, the measure of arc AB plus the measure of arc BC is equal to the measure of arc ABC. So for example, let's say that the measure of arc AB was 90 degrees and the measure of arc BC is 110 degrees, then we would say that the measure of arc ABC is 200 degrees. All right. A couple more definitions. Well, actually one definition. Let's say that we had this circle O, and on the circle we had points A, B, and C. And if I were to draw angle AOB and angle BOC such that the measure of angle AOB is congruent to the measure of angle BOC, then we say that the arcs that are formed by those central angles are also congruent. So, congruent arcs are arcs that are in the same circle or congruent circles that have equal measures. Congruent arcs are arcs in the same circle or in congruent circles that have equal measures. For example, we can see in our picture that the measure of angle AOB is equal to the measure of angle BOC, they're in the same circle, so angle AOB is congruent to angle BOC. Therefore, we say that arc AB is congruent to arc BC. From this, we can write a theorem. This will be theorem 10.1 or 10-1. In our homework book, it is homework theorem 9-3. And it states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. This theorem does not apply if the two circles are not congruent. If I had a small angle here and a large angle here, and I know that the measure of this arc, let's say, is 20 degrees, and the measure of this arc is 20 degrees, those angles, even though those angles are congruent, the minor arcs are not congruent because we're not in congruent circles. These are not congruent circles. Therefore, their arcs are not congruent. I think that gives you enough information that you need for your homework for tonight. If you have any questions, well, I guess when I say homework, I actually mean your classwork for tomorrow. If you have any questions, please don't hesitate to draw me an email. I can't promise that I'm going to get right back to you, but I promise that I will do my best. Okay? Talk to you later.